Hello students. Now let's start with the structure of DNA. The first thing, for understanding the structure of DNA, we need to understand that it is called as 2-deoxyribose nucleic acid. We commonly call it as deoxyribose nucleic acid, but now you need to call it as 2-deoxyribose nucleic acid. It comprises of three different things, and what are those three different things? Then it is sugar, next is nitrogenous bases, and the last one is phosphoric acid. Let's start with the sugar. We said that sugar, it consists of a sugar that is a pentoses sugar, and this pentoses sugar was called as ribose. So here we have ribose right now. What we need to do is we need deoxyribose, because the name suggests that, right? So we need to have deoxyribose, and oxygen should be removed from to the second carbon atom. So here what we can see is second carbon OH is removed and there is only H remaining now. So what we would say is that we have a sugar called as a deoxyribose, and what is it? Then it is 2-deoxyribose. So we have a sugar called as beta D2-deoxyribose. Nitrogenous bases, again it consists of two types, purines and pyrimidines. In purines you have adenine and guanine, whereas in pyrimidines you have cytosine and thymine. And in phosphoric group or phosphoric acids you have a structure something like this. So let's now understand the structure of DNA, or a structure of polynucleotide which makes this DNA molecule. First of all, we have a sugar molecule which is a pentoses sugar, that is a sugar containing 5 carbon atoms, and in this we have deoxyribose. Now from the first carbon, what we are going to do is we are removing the OH, and instead of that what we are adding in this sugar molecule is a base. So what we added instead of OH is a base. So now do we have a sugar and a base? Yes, we have it. And this structure was called as a nucleoside. Moving further, now let's attach a phosphoric acid group onto this. Phosphoric acid is nothing but P attached to 3 OH groups and a double bond O. So now do we have a sugar, a base and a phosphate group? Yes, we have it. And this was altogether known as a nucleotide. So what we have is nothing but a nucleotide. Now what happens is from the phosphoric acid an H is lost, and OH from the third carbon atom is lost, giving us a bond that would be similar to a glycosidic linkage. But now in this case it is P double bond O, remember. Again, suppose if there is one more sugar molecule, let's see what happens. Again, OH and OH from the phosphoric acids and sugar respectively combine, but right now it is the 5th carbon atom's OH that is going to combine. So now what happens? First carbon atom's OH removed as base, 5th carbon atom OH combines with the phosphoric acid, removing a water molecule, giving us a bond similar to glycosidic linkage. What here we have is nothing but a structure of DNA. Now if we observe, students, DNA structure is nothing but a structure that is a double helical structure, and in which both the helix are attached to each other, or they are interacting with each other using bonds called as hydrogen bonds. Further, now if we observe one more important point, then if there was a sugar molecule again behind this or below this molecule, now phosphoric acid before this would combine with the third OH group, and therefore this N right now would be called as a 3' N. Suppose if we go on with the topmost molecule over there, what would happen? If we happen to have a phosphoric group over there, then the 5th carbon OH would combine. So now what we can say is in entire polynucleotide chain, there are only two ends which can be used for its expansion, and those are either a 3' end over here like in this case, or a 5' end onto the top. So if you have a 5' end on the top, 3' at the bottom. If you have a 3' at the top, 5' at the bottom. This was all for a structure of DNA. We will meet in the next module with the structure of RNA. Till then, thank you students.